Earlier, we saw an example of assignment with mathematical operators in Python. We would have a mathematical expression on the right, like 2 plus 3, and a variable on the left to which we assign the results of the expression. So if we had something like a equals 2 plus 3, then a would end up with the value 5. The computer would evaluate 2 plus 3, then take that and assign it to a. Self-assignment isn't actually any different. The only thing that makes self-assignment unique is that a single variable appears on both sides of the statement. To the computer, it isn't actually any different at all because it interprets the right side of the statement before looking at the variable to which it assigns the result. To us, though, it can feel kind of strange. So let's trace through and see how this works. On line 1, we create a variable named mynum and give it a value 5. On line 3, we print the current value of mynum, which gives us 5. The computer basically goes and looks up the current value of mynum, replaces the variable name in parentheses with that value, and then runs a line of code, which here ends up with just print 5, because 5 was the value of mynum. Then what happens? Well, we go down to line 5. Line 5 says mynum equals mynum plus 1. Now, if this was checking to see if the statement was true, we can see very quickly that it wouldn't be. Mynum can't possibly equal itself plus 1. But remember, a single equal sign is the assignment operator. That means this statement reads, assign mynum to the result of the expression mynum plus 1. That statement has nothing wrong with it. So how does the computer evaluate this? Well, once again, it replaces mynum with the current value of that variable. The current value is 5, so it basically replaces mynum with 5. So how does the computer run this? Well, like before, it looks up the current value of the variable mynum and replaces the variable with that value. Here, it's like replacing the variable name mynum with the number 5. So rather than reading mynum plus 1, the statement now reads 5 plus 1. 5 plus 1 is 6, and so 6 is now assigned back as the new value of the variable named mynum. The computer then runs to line 7, which says print mynum, which means go look up the current value of mynum. On line 5, we change the value of mynum from 5 to 6 by adding 1 to it. And so when we print it again, our result is 6. Now, like I said, this feels strange to us. It feels strange to set the variable equal to an expression that includes the variable. And yet the way the computer runs this line makes it make perfect sense. The computer evaluates mynum plus 1 before ever looking at what's going to receive the value after it's done evaluating that. Once the computer evaluates mynum plus 1 and finds that the answer is going to be 6, it then goes and looks at the variable to which it's going to be assigned and finds that the variable is mynum. It doesn't make the assignment until it's done actually dealing with the current value of mynum. As this code continues to run, we can see this done a couple more times. Line 9 again adds 1 to the current value of mynum, takes the result, and puts the result back into mynum. Then line 11 prints mynum and gives a result of 7. Mynum was 6, we added 1, now it's 7. Line 13 does the same thing again, but now it's plus 5. Set mynum equal to mynum plus 5. Mynum was 7, so set mynum equal to 7 plus 5. Set mynum equal to 12. Mynum equals 12. And sure enough, on line 15, mynum now equals 12. As far as the computer is concerned, the mynum that receives the value and the mynum that calculates the value are basically like different variables altogether. By the time it's ready to assign a value to mynum on the left, it's done dealing with mynum on the right. This same exact principle works with all the other mathematical operators we've talked about as well. Line 2 creates mynum and assigns it the value 5. And so right now the variable mynum has the value 5. Run line 4, and we see sure enough, it has a value 5. Line 6, like before, adds 3 to the current value of mynum and sets the result equal to the variable mynum. Line 7 prints that, and the result is 8. 5 plus 3 is 8. Line 9 does the same thing, but now it uses subtraction. Mynum equals mynum minus 3, so set mynum equal to the result of mynum minus 3. Last we checked, mynum had a value of 8, and so this becomes mynum equals 8 minus 3. 8 minus 3 is 5. And sure enough, when line 10 prints it, we're back to 5. And as we go down, we see this works the same way no matter what mathematical operator we use. Line 12 uses multiplication, and sure enough, printing line 12 gives 15, which is 5 times 3. Line 14 uses division, and specifically it uses floor division. So it's going to round the result down to the nearest integer. However, the last value of mynum was 15, and 15 is evenly divisible by 3. So when we print the result after dividing by 3, we get 5. 15 divided by 3 is 5. The fact that we used floor division is the reason why there was no 0.0 on this. If we'd used regular division, even though 3 goes evenly into 15, we would have had 5.0. Line 18 then uses exponentiation. It raises the previous value of my num to the third power. The previous value was 5, and 5 to the third equals 125. 21 is our weird little modulus operator. That's what the percent sign represented. It says, what is the remainder when dividing my num by 3? 3 into 125 gives us 41 with 2 left over. And so our result printed on line 22 is 2. And finally, line 24 does our regular division. The last value of my num was 2. 2 divided by 3 equals 0.6. 6, 6, 6, and so on. And so that's our final value of my num when line 25 is run. The key takeaway here was we only ever really had one variable, my num, we just use it everywhere. So we had one variable whose value kept changing. And most importantly, it always changed based on the former value of that variable itself. Now it's also important to note that this works no matter what is on the right side of the assignment operator. Here, on line 2, we create a new variable called myString and give it the value hello world that we've seen before. On line 4, we print it, and we see it as we expect. On line 7, we run this funky little piece of code. We'll talk more about what this actually means later, but for now, know that the length function returns an integer that holds the length of whatever was in the parentheses. If you're using a string, it's the number of characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 characters in hello world. This then converts the number 12 to a string 12, and it assigns it to the variable myString. When line 8 runs, it now has that new value, 12. We could then do that again. On line 11, we again set myString equal to the length of my string, and there were only 2 characters in 12. So now our answer is 2. The point here is that we can use self-assignment for things besides just math. We might not do it often, but it will definitely come up sometimes. The important takeaway here is that as far as the computer is concerned, it really doesn't matter if the variable receiving a value is used in the calculation of that value. The computer evaluates the right side of the expression to get the value, and then it assigns that value to the variable itself. It first evaluates the right side, and then once it knows the answer to the right side, it takes that value and puts it into the left side. Having the same variable on both sides doesn't affect that process, in large part because the very first thing the computer does is replace the variable name with the value of that variable. It then does the evaluation with the value. So by the time it has an answer, the variable is no longer part of the equation.